Hello everybody, welcome to Design Studio. I am your friend Mrigan and today we are going to do stress analysis, structural analysis in ANSYS. This is the problem statement where you can see all dimensions are given and the pressure and Poisson's ratio, PR is Poisson's ratio is given properly. So we are going to solve this problem in the ANSYS workbench. So let's start the problem. Basically, ANSYS is the best software available in the market. So we are going to discuss today about the ANSYS. For that, you have to make the directory first. You have to set the directory. For that, you just save your name clear first, all the data, whatever is there, earlier file. So clear the name of the file and put your name, select the directory and select the problem. ANSYS is the one of the best software available in the market and it is very popular also, and you can download it free from the ANSYS website. So today we are going to discuss basically a structural problem. We will simulate a structural problem, stress analysis in that problem. So as you seen in the problem, we have done the basic dimensioning and pressure, all these things. So let's start. So first of all, we have to choose the preference and then we have to choose element type. In element type there are many element types like link, beam, but today we are going to choose solid because this is a 2D problem. So we will choose a simple quad. We will select it as a plane strain problem because you know it's what is the conditions of a strain, and in this problem we are we can easily understand that this is a strain problem. Now you can see this error message, we can remove it. Now the first of all we have to choose the type of material. For material property we will go here and put the values of Young's modulus, which is given in the diagram, and the Poisson's ratio. After completing it, we will go to modeling. We will create the key points to create the geometry. There are 4 golden rules to the ANSYS or any FEA problem. That is, first of all you have to decide the geometry of the problem. Then you have to define the nodes, key points, all those things. And second thing, you have to define the material. For material you are going to put the Poisson's ratio value and Young's modulus value. And the third is you are going to apply constraints or boundary condition. And fourth is the load. So these 3 are the golden rules of FEA analysis. So now we are going to make the key points by the coordinates. This is the 6th key point, which is 0,1, and you can see we have created these key points. Now we will go and select lines. In lines we will select all lines. We will pick these line. While picking the line you should remember that you either go clockwise or you go anti-clockwise, but don't mix it, otherwise you will face some problem. So after line we will make arc, then we will select two key points and the radius of the arc. So radius is 1, and hence this is the problem statement. This is the geometry, which is similar to the problem statement whatever you have seen in the problem. Now we will proceed further. The third basic thing which we are going to do is we will create the mesh. So first of all we have to create the area. So we will select the lines and we will create the area. If something goes out of the screen, then you can plot it. Go to the plot option and there are a lot of options you can select to plot nodes, lines, areas, etc. Now we will go further for the meshing, and we will select default attributes. Now we will take size control, and in size control we will define the element size. This is very important because if you select too much small element, then your system has to have a good RAM, otherwise it will hang, because ANSYS for calculation needs more RAM. So it is better to give a fine mesh, but not very fine, otherwise calculation will be very high. So after size control we will mesh the area, and we will go to free. We are not going for mapped because in case of mapped all four sides should be proper. So you can see how beautiful mesh is there. There is no element whose aspect ratio is very different. Most of the elements are similar, so we can expect that the aspect ratio is 1.1, 1.2 average aspect ratio. So it is beautiful. We will further go and we will define the load conditions. For load we will define load, and first of all we will go for setting and we will apply constraints. So displacement means constraints. This portion is a symmetric boundary, because if you mirror this, then this structure will be looked like a pull, so a bridge. So this portion should not go down or up. It should be I mean that the thickness of the portion should be the uniform. Arc radius can be changed, but the thickness will not be changed. So you can see here nodes by the plot, and see we have provided constraint at bottom, and now we will apply pressure. So this is the pressure option. We will put it on line and we will put some values. It is taken by the problem statement only. So this is the thing we have done. So all four things we have covered. We have made geometry, we have made material, we had defined load, boundary conditions. So we can go for solution. So we will solve now this, and wow, it's solved. Yeah, it's solved. So simple, no? Now we will plot result. We will see what is the result. So you have to call the file. So this is the file which I had made at the starting. Yeah, this is, and we will open it and we will plot the contour plot, nodal solution, and we will see degree of freedom, x component of displacement, and you can see yeah, this is the solution. So we have achieved it. Yeah, correct. Here you can see the degree of freedom in x dimension. You can see stresses, so many things are there to see, and you can animate also. So x component is stresses. Here mostly stress will be concentrated at the starting of this arc. So now we will plot one missed stress. Here you can see stress. Red is the maximum stress portion. So we are going to do a structure. We have completed our structural analysis, and we are going to do an animation. So yeah, so you can see now how it is going to behave when force will be acted, pressure will be acted on the surface of this structure. So beautiful. Now we will show you some more thing. We will animate deformed shape, and yeah, so you can see how deformation is going to take place. So you can see that we have mentioned that the thickness should not change. So thickness is not changing, but the arc is going to deform. So let's see this thing, and yeah, very nice.